Okay, we're going to introduce nuclear chemistry and talk a little bit about nuclear stability. Right, so a term that maybe you haven't heard before is nucleon. And a nucleon is a particle that we find in the nucleus. So two options, protons with a positive charge, neutrons with no charge. Both are nucleons. So a proton is a nucleon and a neutron is a nucleon. Nucleon means, hey, this is a particle that's found in the nucleus. Okay, a nuclide, a specific nucleus. So a specific number of nucleons. So a specific number of protons, a specific number of neutrons. It can be represented in two ways. So first we could use the notation seen in the image. So what am I talking about? Right here. Now, to be fair, we don't need to have this number written. So it could have just been written like this. And the reason is this number just comes from the periodic table, this 6. So I don't have to tell you it because you can look it up on the periodic table. Or we could write the element name with the mass number, because again, I don't need to tell you the atomic number because you just get that from the periodic table. So I could just say carbon 12. Okay, an isotope. Same atomic number, but different mass numbers. So we have the same elements. You can see here we have the same symbol, Li, Li, Li. Also, you can tell we have the same atomic number, 333. So same number of protons. They all have 3 protons, but they have a different number of neutrons. How do I know? Look at the mass numbers. The mass numbers are different, 6, 7, and 8. How do I find the number of neutrons? I do subtraction for this problem. So I'd have 3 neutrons here. I would have 4 neutrons here, and I would have 5 neutrons. So isotopes are atoms of the same element that have a different number of neutrons. Now, not all isotopes, not all nuclides, not all nuclei are stable. And this is something that you should recognize. It is the band of stability. So all nuclei with more than 83 protons are unstable. Okay, so if we look right here, 83, which is right here, everything over here, all of this is unstable, radioactive. Okay, and then you could see for non-radioactive isotopes, you can see it's very narrow. And when atoms are small, so say when they have 10 protons and we go up, in most cases, it's going to be a 1-to-1 relationship. So 10 protons would need 10 neutrons to be stable. But then when we start getting to bigger numbers, like let's look at 40, and if we go up at 40 and look where it's stable, I need 50 neutrons. So as the atomic mass, as the atomic number gets bigger, I'm going to need more neutrons to stabilize more protons, okay? But when I get above 83, that's it. They're all unstable. There's no stable versions. Elements can still have unstable versions, no matter what their atomic number is, but for atomic numbers above 83, all unstable. So when we look at our periodic table, how can we tell? So if you look right here, do you see this atomic mass? It's in parentheses because it's unstable. So I'm like, I'm guessing this is the atomic mass. There are a couple of exceptions. Do you see right here? This one is in parentheses, and right here, this one is in parentheses. Those two are smaller than 83. But the rule is anything over 83, so you see right here, 84, and everything bigger is unstable, is radioactive. That means, bam, it decays. Okay? Again, you don't have to memorize this. You don't have to memorize which elements are all radioactive, have all unstable isotopes. What do you notice about the atomic mass? It's in parentheses. It's like, I guess. Okay? So when the atomic mass is in parentheses, that means every single isotope of that element is unstable. it's radioactive. Some isotopes with fewer than 83 protons are unstable. I showed you 2 where all of their isotopes are unstable, but other elements can have unstable versions. Like look, carbon-12, stable, carbon-13, stable, carbon-14, radioactive. All 3 of these oxygen isotopes are stable, okay? So different elements can have unstable versions that will decay, but if the atomic number is greater than 83, all of the versions are unstable. All right, so let's look here, and we're going to look at some stability. So watch this. If I'm going to put a proton in here, it tells me, oh, this is hydrogen, and I can just open these just so you could see what's going on. And it says that it is stable. If I add another proton, it becomes unstable. Why? What do I need to do to make it stable? Well, let's try and add, oh, look, when I add a neutron, it stabilizes it. We are not going to focus on electrons right now, but here I do want you to just see, do you see how the net charge is +2? That's because I have 2 protons, and I don't have any electrons to balance it, so that means I have a charge of +2. What if I add another neutron? Oh, it's still stable. Because remember, we always think about, for sure, a 1-to-1 ratio. So if I have 2 protons, I can at least have 2 neutrons. What if I add another neutron? Oh, now this is an unstable version, but it's still helium because I have 2 protons. Add another proton. Oh, wait, now it's stable. What if I add another proton? The name of the element changes, but you see it is unstable. If I add another proton, that doesn't help. So what do I have to do? Add a neutron? Oh no, add a neutron? Okay, so now we are 1-to-1. You see our ratio up here? What if I add another neutron? Still stable. What if I add another one? Oh no, now it's unstable. So we add a proton. This is carbon, right? So let's add a neutron. Now it's unstable. So let's add a proton, and let's add another proton to make it 1-to-1. So this is oxygen. So I have 8 protons and 8 neutrons. What if I add another neutron? Oh, still stable. Add another one. Oh, still stable. Add another one. Oh, now it's unstable. Okay, so you can see the relationship between protons and neutrons. And in this case, there we go. Now we are stable here, okay? You could remove neutrons, add neutrons, but again, this is a good way to visually see that an unstable nucleus is going to break apart. You saw it shaking, right? It's going to break apart. So what happens when an atom is unstable? So what happens when something is radioactive? It will decay. What does that mean? It's going to break apart. The nucleus is going to break apart. The nucleus will continue to break apart until it is stable. So it's going to break apart. And if that new nucleus is still unstable, it's going to break apart again. Okay? So some elements can get to stable with one break. Some it will take more than one. So here's an example. When uranium-235 breaks apart, we got to hit it with a neutron to happen, but when it breaks apart into 2 isotopes in this version, barium-144 and krypton-89. Both of those are also unstable. Okay, so then the reaction has to continue. We have to get to something that's stable at the end. So that is an introduction to nuclear chemistry and nuclear stability. I hope you learned something new today.